All right, gang. Welcome back to Lou's Whiteboard. Today we're going to talk about hex, hexadecimal, which is base 16. So here we go. So here's the values: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So some of you guys are probably saying, what? Yes. So this represents the ability from representing from 0 to 15. And the reason we came up with this is basically to have a single placeholder. So if we wanted to show a 10, instead of having two digits, we can have one digit to represent that. So that's what this power of base 16 is for. It's for positioning. So, again, like an example, this would be 10, 11, 12, 13, 14, 15. So it is base 16. Remember, we got to count 0 to gain. All right. So, as an example, if someone said, what is the letter, or what is A equal in decimal? Well, that's easy. That's 10. No big deal there. Where it gets tricky is when we're saying, like, A3. Now, that's tricky because now you got to write this in two parts. So I'm going to show you how to first do it in binary because it's easier this way. And since we already talked about binary in class, so let's go ahead and do this real quick. So here's our example. So we're going to each one of these we're going to use 4 bits and 4 bits, because remember, 4 bits can get us 0 to 15. So this is how we're going to write it out. So we're going to write it. So we're going to convert this into base 2. Is going to be our answer. So again, let's draw out our little 4 little bits. 1, 2, 3, 4. All right. So again, we got 1, 2, 4, 8. Okay. So we're going to start with A. So we know A is 10. So can we subtract 10 from 8? Yes. All right, so I'm going to do the math here real quick. So 10 minus 8 gives us 2. Okay, so can we take 2 from 4? No. Can we take 2 from 2? Yes. And there's nothing left, so that's a 0. All right, pretty good. Pretty easy so far, right? And let's erase that. And now I'm going to switch another color to represent the other part. All right. Can we take 3 from 8? No. Can we do 4 from 8? No. Can we do a 2? Yes. All right. So 1. There we go. So that is how mathematically we express A3 in binary. Now, if we wanted to convert this answer to decimal, base 10, so now we need to write out all 8 bits. So let's go ahead and get some room in here. So we got 16, 32, 64, 128. So we're going to put the 1, the 0, 1, 0, 0, 0, 1, 1. There you go. So we know this is going to be an odd number because why? Because the last bit on the right is a 1. It's on. So we're going to add 128, 32, plus 2 plus 1. There we go. So, all right, let's get our math calculation going on. Little that we knew today was going to be a math class, right? So true. So 128 plus 32 plus 2 plus 1. So that should come out to be 163. So that's how we would take a number from hexadecimal, like an example, A3, and convert that to binary, and then from binary to base 10. It's the easiest way to do it. So again, in real life, we would just use a scientific calculator to figure this stuff out, but if we're going to be taking some certifications, things like that, it's good to know it that way. All right. So let's try another one real quick and see how we can do. And again, if you're having problems, stop by in class and we can, come by my office hours and we can work on these. Okay? All right, I'm just going to erase this number line. Oh, I'll just leave it there. Why not? All right. So we're going to try to solve for let's go with one D. All right. That'll be nice and easy. So again, let's get our number line out going. So we got 1, 2, 4, 8, 16, 32, 64, 128. All right. So we know gonna put a little base 16 so we know what this is. And now we're going to go ahead and do base 2. All right. So we know 1 is going to be 1, right? So that's going to be 0, 0, 0, 1. Okay. That's easy. And we know D is going to be 13. So can we subtract it from 8? Because remember, we're only going to be using the first 4 bits. So the answer is no. Can we? Oh, wait a minute. Yes, we can. I was looking at the wrong number. So, yeah. So we can. So we got 13 minus 8. So that gives us 5. Can I subtract that? Yes. 4, 0, 1. 1, 1, 0. All right. Very good. So now we're going to go back to decimal and let's change our color. So based 10. All right. So we're going to line these up. 0, 0, 0, 1, 1, 1, 0, 1. Again, we know this could be an odd number. So we've got 16 plus 8 plus 4 plus 1. Okay, so that's 10, 19, 20, 29 is our number. All right. If you found this helpful, please tell me in class so I know, so it'll motivate me to do more of these types of things. All right. I appreciate you watching. I'll see you guys in class or online or office hours. All right. Catch you later. Bye.